part C of this same problem, we now have 15 milliliters, so we're beyond the halfway point to the equivalence point. So if we looked at our graph, we're at point C. We're going to rise a little bit because we're continuing to add some more base, so it's going up, but we haven't yet reached the equivalence point. Now you don't need to know that in order to work this problem. We just need to work with the numbers we are given. Weak acid, strong base, one-way reaction. Notice I left the sodium out because that's just a spectator ion. As a one-way reaction, I use something called an IC-F table, okay? F stands for final, where we put in moles, which is a way of doing a limiting reactant problem. Now from part A, we calculated the moles of HA, and notice, as this reaction is taking place, what are we adding? We continue to add more and more of this. We're always starting with the exact same amount of that weak acid. So the value that sits here is never going to change. 0.00498. That is what is in the flask that we're titrating the sodium hydroxide with. So to get the moles of the sodium hydroxide, the hydroxide, it will come from the moles of sodium hydroxide. Every time you have one sodium hydroxide, you're going to have one hydroxide. So we can use the information about this. It's 0.249 moles per liter, but in this case, we're going to multiply by, that's a times, multiply by how many liters of the base we now have. It's 15 milliliters, or 0.015 liters. That's going to give me the moles of sodium hydroxide, which is 0.003735. And we can plug that into our table, 003735. Now, we're just imagining we're back to the very beginning and adding this much base. So again, if you're back to the beginning and you add that much base, nothing's happened here yet, and we don't care about the water. Once this much gets added, we consume all of it because it's the smaller of the bunch. This reaction goes to completion, so it goes until it uses it all up. And then we fill out the rest of the change line based upon this number. So we're going to use up this amount of the acid. We're going to produce this amount of the conjugate base. Okay, so that will give me my F line. I still have some of the weak acid present, 0.0012, and I'm carrying an extra bit along for the ride. I've consumed all of the base. It is gone, and I have remaining the conjugate base of that weak acid, which is this number here. Now, when I get to the F line, I always have to decide what is my next course of action. What's my next step to take? Well, the next step is to look at what I have left. I see that I have some weak acid left and some of its conjugate base left, and that's a buffer. And buffers get the joy of using the Henderson-Hasselbalch equation. I call it a joy because it saves us so much time. I told you you can use moles instead of concentration when you're doing these problems because moles divided by volume gives you molarity, and the volumes are the same for both of those because it's all contained inside the same flask. So we take the negative log of the Ka value, which was given to us as 1.54 times 10 to the minus 5, plus the log of the moles of the base, which is this number. That's the conjugate base of the weak acid. And moles of this acid, 0.001245. Now as I look at these two numbers, I see that there's more base than acid. So it's going to be rising that pH up ever so slightly. So this gives us, the Ka value gives us a kind of a where it would be if we had equals, and when this gets bigger it's going to raise it. If this got bigger on the bottom it would lower it because that's the acid. Alright, so what do we have for the numbers here? Well, we have 4.812, which is what we got in the previous problem, plus the log of that ratio, which I did not actually, plus all of that, and I didn't write that number down. So when you add that bit there, I said it would bring it up a little bit, and it did, 5.288. 9. So it brought that pH up ever so slightly. Like we see in the picture here, at point C, it is a little above where it was at point B. This is where it was at point B, right here. And it came up ever so slightly.